This is a short video just to explain the global hydrological cycle within a drainage basin. This is the first part of the hydrosphere course that we need to understand. So what we need to do is to draw out the profile of a hill with a river at the bottom. And we're just going to explain the different paths in which water can take from the atmosphere, either on land or through land, back into the river channel, where it'll then go out to sea. So to begin with, we've got our main input. So our main input will be the rain. So we have precipitation as being our first and only input. Now, at that point, when it rains, well, two things are going to happen. So the first thing is going to be that it may well reach the ground, and when it reaches the ground, it will infiltrate. So infiltration is a movement of water that goes from the surface into the water. Now, depending on what the texture is like, so if you remember before, where we've got really sandy soils, then that infiltration rates are going to be really, really rapid. Where we've got soils that are maybe overlapping and we're compact like clay, then what we'll have is much slower rates of infiltration. So if water doesn't infiltrate along the surface, then it can either go into surface storage, so the technical term for that is a puddle or a pond or a marsh. It can be stored there on the surface. But the water, if it doesn't infiltrate and it isn't stored in the surface, then its next and only route after that is that what it will do is it will then flow as surface runoff. So surface runoff is when the whole surface of the soil is totally saturated and the water is running downstream, downhill towards the streams from there. Surface runoff can obviously then just continue into the channel. But going back to infiltration, okay, water can then go as soil storage. Water can be stored in the soil as moisture. But water could then either, at that point, flow underground as through flow, flowing through the soil, until it reaches the river underground. Water that infiltrates and is stored in the soil but doesn't flow through the soil, but gravity continues to pull it down, that will end up undergoing a process of what's called percolation. So percolation is when we're looking at parent material like sandstone, for example, which is really porous. It can then enter as groundwater, where it can be stored, and rocks that store soil are known as aquifers. So we've got storage in the soil, we've got water that hasn't flowed through the soil downhill and into the river that way, but it's continued vertically down into the hill. will be percolated, where it then enters another store, which is rocks like sandstone, which are permeable, or limestone. So sandstone, limestone are examples of rocks that are permeable, and that's where water can be stored underground. From there, that will take its time and will flow as groundwater flow. Until it too reaches the river. Now, just to stop at this point and say that, well, what we've got is that this first one, the surface runoff, we're really talking in time scale that we could be talking hours. For this route to take place, where it infiltrates into soil, stored in the ground, flows through the soil, and eventually ends up into the river, this process here, we're really talking days to weeks. And this last one, where it's moving into the soil and then soaks into rock, is stored in the rock, flows through the rock and into the river, we're potentially talking years, in some cases hundreds or thousands of years for it to move. So we're really thinking here, not just in terms of where it goes, but in the time scales in which things happen as well. Of course, this is really simplified because what we're missing is that we will have vegetation. And we know that plants will transpirate water out as part of photosynthesis. So we have an output. So we have water as part of photosynthesis. Trees will draw up water through their roots from the soil, and they will transpiration. They will move the water back into the atmosphere. So transpiration is one of our outputs. However, rain will also fall on the tree. So put another cloud in. We've got rain falling on top of the tree, and that precipitation will land on the tree. But we also know that water will evaporate out, and it'll evaporate out either from the river itself, or evaporation takes place from the soil, evaporation takes place from the plants. But what we also have is evaporation. So evaporation will be that rain just lands on the plant, lands on the leaves, and the sun comes out and the water is evaporated straight off of the leaf. Or water can be evaporated directly from the river, or water can be evaporated directly from the soil. So I'll put that back in there. So water can be evaporated directly from the soil like that. So put that in. There's our outputs. What we're left with is the water that does go into the river, either flowing along the surface of the soil and landing in the river, or flowing through the soil itself and going into the river, or flowing through the ground and entering the river, ends up as what's called channel flow. Okay, so that'll just be the water flowing out to the sea. So it's been transferred from the hill, from the rock, into the river, and then out to sea, and that would be our last flow, which obviously would end up in evaporation. The last bit would be that the time scale here for this, be minutes to hours for this taking place. This is happening all the time. So this is like a really short-term cycle. So the key idea here is just to recognize how water can move in different paths to the river, but also the scale at which things takes. To remember that a flash intense amount of rainfall will produce a lot of surface runoff. that water will tumble into the river really, really quickly. Persistent rainfall will have more of a chance to soak in, depending on what the soil type is, depends on how much of that infiltrates in. So clay soils are less likely to infiltrate a lot and more likely to produce surface runoff. Podzol soils are more likely to have more infiltration and less surface runoff. So that soil type is more likely to have water being stored in the soil and then flowing through the sandy soil into the river, or it'll continue down into the sandstone and go through. And that's how water moves in the cycle.